Hi everyone, in this video I'm working through question 16 part C of the 2019 Advanced Math exam in New South Wales, so for the HSC. This was actually the very last question on this exam, so in theory it's the hardest. It's not always true, but often it is the case that the last question on the exam is the hardest one. There's two parts to this question, and the student who was struggling with this was particularly having trouble with part 2. And actually, they submitted this question on the Board of Studies forum, and their specific question was, where is the triangle? And that'll make a bit more sense once I work through the question, where is the triangle, what's that all about? So let's just read through the question, and I'll work through part 1 and part 2, particularly given part 2 requires part 1 to really be able to give it a fair crack. So we're given this diagram, and it shows the region capital R bounded by the curve y equals x to the lowercase r, where lowercase r is some number greater than or equal to 1. So we've got a region bounded by that curve and the x-axis and the tangent to the curve at the point 1, 1. So that's kind of how we define our region capital R. Part 1 of the question says, show that the tangent to the curve at 1, 1 meets the x-axis at the coordinates r minus 1 on r, comma 0. And then part 2 says, using the result from part 1 or otherwise, show that the area of the region capital R is r minus 1 on 2r, r plus 1. And the approach I'm going to take will use that result from part 1. So I'm not going to be in the or otherwise territory. I'm just going to follow the scaffolding that the question writer has given us. So what I've done here is I've recreated the diagram just so that we can annotate it if that proves helpful. So we've got our curve y is equal to x to the r. We've got the x-axis obviously, and then this tangent, which is a straight line, the tangent at the point 1, 1. This region R is what's inside those three lines. So part 1, we were being asked to show that the tangent, in other words, this straight line here, that meets the x-axis. So it meets the x-axis, in other words, this point here, at the coordinates were r minus 1 on r, comma 0. So in other words, we're being asked to show that this point here has coordinates r minus 1 on r, 0. Obviously it's comma 0 because it's on the x-axis, so the y value is 0. So it's really about finding this x-intercept of the tangent. Now, the first, I guess, piece of mathematical knowledge we need to use is knowing that this tangent is by definition a straight line. So if it's a straight line, it would follow the form y is equal to mx plus b. So if we can find values for m and values for b, we should then be able to set y to 0 to then work out what x is, and hopefully it turns out to be r minus 1 on r. So step 1, let's find m, the gradient of the line, and we can use a little bit of calculus here, because if we can differentiate our curve, that gives us our gradient at any point, and given we know we're looking at the tangent at point 1, 1, we can then work out m. So first thing to do, I'll get the first derivative, y dash. Now y dash of x to the r, we bring the exponent down and then subtract 1, so it would be rx to the r minus 1 is our derivative. Now we know that at x is equal to 1, this point here, the derivative, the tangent is going to be y dash, sorry, the gradient will be equal to r times 1, because we've got x is equal to 1 to the power of r minus 1. So basically we're saying at this point of the curve, the gradient of the curve, which we can find using the first derivative, is r to the x to the r minus 1, but x here we've said is 1. So 1 to the power of anything is just 1. So that means our gradient is just r. So that means that the gradient of this whole line, this straight line here, m, is equal to r. So that's the first unknown. The next unknown we need to find is b. Now, we can use the fact that we know this tangent line crosses through the point 1, 1 to then solve for b, because we've got m already, we've just said it's r. We know that when x is equal to 1, y is equal to 1, so that should give us enough. So we can say, given the tangent crosses 1, 1, we can say that 1 is equal to r, because we worked out m is equal to r, times 1 plus b. So if I rearrange for b, we can say b is equal to 1 minus r. Now I might just have to turn over at this point, but we can now kind of write our straight line for the tangent. So if I just turn over, we can say therefore the tangent line will be y is equal to mx or rx, given we know m is equal to r, plus b, and b we just worked out is 1 minus r. Okay, so now we want to find the x-axis intercept, or in other words, when y is 0. So we can say when y is equal to 0 for this tangent line, we get rx plus 1 minus r is equal to 0. So that would mean rx is equal to, and I'll just bring this over, so it would end up being r minus 1. And that means x would be r minus 1 on r. Therefore, the tangent crosses the x-axis at the coordinates, well, the x-coordinate is r minus 1 on r, and the y-coordinate is 0. Sonic boom! So r minus 1 on r, comma 0 is what we had to show. So that's how you get through part 1. So now, if we move on to part 2, which is where the student who submitted this question was having a bit of trouble, we're asked to show that the area of the region R is equal to R minus 1 on 2R, R plus 1. So that's what we need to show. And if I kind of come back to our diagram, this is where, maybe I'll use another colour here, maybe I'll just use red. The student had asked, where is the triangle? And so I'm just going to draw on a triangle here, just to make it really clear. And there's this tangent line here. If I just shade that in, the basic idea is if we want just this area of just this blue region R, we can find the area under the curve, under the whole curve, and then subtract from that the area of this triangle, and then what would be left is just the area that we're looking for. So that's the basic idea. Where is the triangle? Well, it starts at this point 1, 1, it comes straight down, and then it heads back over to this intercept that we just found the coordinates for. So that should give us everything we need to work out the area of this triangle. And to get the area under the curve, we'll just use classic calculus techniques. So I'm turning back over. Maybe the way I'll write that is I'll say the area of R is going to be equal to the area under the curve minus the area of the triangle. I'll just put a triangle for the symbol. So if we can find each of these areas one at a time and then put them together, that will give us hopefully what we're being asked to show. So let's start with the area under the curve. So the area under the curve will be equal to the integral, and in terms of the boundaries, we're going from 0 up to 1 because we want the whole curve here, all of that area, and we know that this point here has an x value of 1. So we're looking for the integral between 0 and 1 of our curve, which was x to the r dx. And thankfully this is a very simple integral to evaluate. That's just going to be, we add 1 to the exponent and divide by the new exponent. So x to the r plus 1 on r plus 1 between 0 and 1. So evaluating that, we'll do the 1 and then we'll do the 0. So that will give us 1 to the r plus 1 on r plus 1 minus 0 to the r plus 1 on r plus 1. 0 to the anything is just going to be 0. 1 to the anything will be 1. So this bit disappears and we end up with just 1 on r plus 1. So that's the area under the curve. Now I'll have to turn over and we'll do the area of the triangle. Now the area of a triangle, hopefully you remember, is a half times the base times the height. So for us, what's the base of our triangle? So let's go have a look. The base of this triangle will be the length from 0 up to here, which is 1, minus this distance here. And that's where part 1 comes in, because we just showed that this coordinate, the x value, is r minus 1 on r. So this distance here, we worked out in part 1, is r minus 1 on r. And this distance here, we know is 1. So that means this distance here, being the base of our triangle, is 1 minus r minus 1 on r. So that's what we can put in for the base of our triangle. So it's going to be 1 minus r minus 1 on r times the height of our triangle, which thankfully is very simple. It's the coordinate 1, 1, so this height here we know is just 1. So we just put 1 there, and now we can just evaluate this. So it's going to be a half times, and I'll get a common denominator, so we'll do r minus 1 all over r, and then the times 1 can just drop off. So that's going to be a half times r minus r plus 1, so you've got to be careful with your double negative on r. 2 r's cancel, so it just becomes 1 on 2 times r, or 1 on 2r. Alright, so now we've got our two ingredients. We've got the area under the curve and the area under the triangle. So now we'll put those together to say, therefore, the area of r, being what we really care about, is the area under the curve, 1 on r plus 1, 1 on r plus 1, minus the area under the triangle, 1 on 2r. And now we just need to rearrange this a bit. So we'll get a common denominator. So we'll multiply each side up. So we'll get 2r minus r plus 1 over this common denominator 2r, r plus 1. So that's going to be 2r minus r minus 1 on 2r, r plus 1. And that's going to be 2r minus r is just r, so that's going to be r minus 1 on 2r, r plus 1. And is that what we were being asked to show? R minus 1 on 2r, r plus 1. R minus 1 on 2r, r plus 1. Perfect.
Panic boom!
And that's how you do that question. So that was the very final question of the 2019 HSC Advanced Math exam. Where is the triangle? Well, the triangle was here. And I guess in terms of thinking, is this is this worthy of a final question of an advanced exam? It's probably not the hardest final question there's ever been. Probably not the easiest either. It's probably, you know, somewhere in the middle. I guess for an advanced student, where the difficulty might come is this to the power of r means you're not using your calculator at all. You've got to keep everything in generic terms, and you really need to bring together a whole bunch of your calculus knowledge. So advanced math is kind of where you start to really learn calculus in high school. And so this final question is kind of testing just how well did you learn all those concepts. Did you learn about tangents and being able to work out that the first derivative at a particular point gives you the gradient? Do you know that a tangent is a straight line? Do you know that the area under a curve is the integral between those points? And then, you know, marrying that up with a bit of knowledge of triangles. So you really did have to bring together quite a few different types of mathematical knowledge. And yeah, you could kind of see how at the end of a long exam, this might be quite tricky. It was only worth 4 marks, so I guess that's fair enough. There were other parts to question 16. But hopefully, if that was a question that you were struggling with, hopefully this explanation you've found helpful. So yeah, there you have it, and tick boom.